Hello and good morning, Cisco Networking Academy instructors taking the Python Programmability Initiative course. In this video tutorial, we're going to take one more look at lists and how you would create a shallow copy and what the implications are of shallow copies and how you can create a deep copy of a list. And so this video tutorial will demonstrate three individual ways that you can create a shallow copy of a list and one way that you can create a deep copy. Now, the semantics between the two come down to whether or not we have what are referred to as collection data types. So we've got mutable data types like a list or a dictionary, but the traits and characteristics of a list make it a collection data type. In other words, it can collect up other data types, and remember that we can have a list inside of a list. And so when we have a collection data type or collection object inside of a collection object, that is when it's going to matter as to whether we're making a shallow copy or a deep copy. And here's where an example might come into play. So let's go ahead and create the original list. And the original list will simply be a list that contains other lists. So this will be a list of 1, 2, 3. Then we'll create a list of 4, 5, 6. And then we're going to go ahead and create a list of 7, 8, and 9. Whoops. All right, so there we have the three lists that are inside of original list. So now let's go ahead and say ID original list. Let's get the location in memory as to where that object and its values resides. So that is the memory location where it resides. So now what we're going to do is we're going to take a look at how we can create three shallow copies. Now, shallow copies might give you the impression that you're creating a 100% new, mutually exclusive, and independent list. However, when that list contains other lists or collection objects, such as dictionaries, that's where we may run into some confusion. So let's go ahead and create first list. So first list is simply going to be what we would think of as a copy of the original list. So if I were to say first list and then use the list function itself and then put original list in here, let's now go ahead and say ID first list. Again, this gives the impression that we now have a mutually exclusive 100% independent copy of the original list. Let's take a look at the two other ways that we can create shallow lists. So the next is going to be second list. And second list is basically going to say original list dot copy. So now if I was to say ID on second list, you can see that once again, we receive what appears to be a brand new list. And in fact, we are receiving a brand new list. Remember, it's going to be the elements, the collection object or collection data type elements in these shallow copied lists that are going to be impacted by the fact that this is a shallow copy. So again, you are getting a new list. However, it's the elements in the list, and specifically the collection types of objects like lists that are going to be impacted here. So let's do the third and final shallow copy, which is a slicing notation. So I'm going to say third list is going to be assigned the value of original list, and we'll use that slicing mechanism here where, remember, if there's no leading character, we've got a 0, and then this is going to be the end of the list. So in other words, all objects that are in, or all elements that are in that list. And so now let's say ID third list. So that's three different ways that you can create a shallow copy of a list. Remember, if you were to get confused, you can always say help list right from the interactive interpreter CLI. It's going to bring up what are referred to as the help pages. For those of you in the Linux space, these may look very familiar as man pages. And then let's type in copy. And you can see here that that's exactly what we did. Return a shallow copy of the list when we used the copy method. When I said, I believe it was second list gets the value of original list dot copy, open parent, close parent. So again, we received shallow copies. So what is the impact of doing a shallow copy when you have collection type objects that are inside of that list? Well, here we're going to find out right now. So let's first go ahead and say first list. Let's make sure that they're all the same. Second list, third list, and again, we've seen the original list. Now, remember, a new list is being created. It's the elements in the list that the shallow copy is impacting, and here's how it's going to impact it. So let's say that after I've made these copies, thinking I now have 4 independent lists that would not, changing one will not impact the other, let's do the following. So on the original list, I decide that I want to change the first element, and which is the first list 1, 2, 3, and in that list, I want to change the first element of that list. And I want to change it to the string hello with an exclamation mark. Then I decide that in the first list, I also want to make a change, but here I'm going to change the second element in the list at index position 1, and then I'm going to change the second element, the second element inside of that second list, 4, 5, 6. In other words, I'm going to change the number 5, and I want to change that to 9999. And then I go into second list, and here we're going to change the last element, and again, I could say 2, or I could say -1. And then let's change the number 9, which would also be -1. Again, using those negative index positions in order to get the last element of that last element, which is going to be the number 9. And let's go ahead and we're going to change that to, we'll say goodbye. All right, and we'll leave the third list unchanged, or so we think. So now let's go ahead and let's see what original list looks like. Well, this may be catching you off guard. The change we made to the original list was simply to change that element to hello. However, because we did a shallow copy, what you end up with these collection data types is not mutually exclusive, independent lists that are these elements here. You end up with references to these values. And how could we check that? Well, what if I was to say ID, original list, and then let's go ahead and look at the location in memory where the first element in the original list, which is now this hello 2-3 list, where does that reside? Okay, let's check it out and let's see. Original list, I'm sorry, we're going to check first list. So first list, and we'll see what memory location that one is in. And as you notice, it's in the first one as well. Well, what about the second list? Oops, one too many lists there. What about the second list? The exact same location. Now, when we look at the third list, we see that the changes have also taken effect. So, for completeness here, if I was to say third list, and we looked at the first element in the third list, which is that list hello 2-3, again, they all share the same location in memory. Because when you do a shallow copy, the lists that we're working with, the collection objects here, right? These collections of objects that are here, we're not getting new, mutually exclusive, independent versions of these. For these, as you just saw right down here, all we're getting are pointers that are pointing to these original mutable data type lists. And that's what happens in a shallow copy. And the unintended consequences of this could be that you think you're making a copy of the original list that you're then going to go off and work with, not impacting the original list, only to find out that the original list has actually been changed, because all of these collection data types here that are inside the original list are simply pointers. Now, again, I keep stressing this, and I can't stress this enough. When you do the shallow copy, the list that holds these three lists, that is in fact a new mutually exclusive independent list. It's just that the element members in those new lists are pointing to the original list locations in memory because we did a shallow copy. And hopefully that is making sense. So now let's talk about how we avoid that. Well, the very easiest way to avoid that is to do what's referred to as a deep copy. So let's go ahead, and first we need to say from copy import deep copy. Now I could simply say import copy, but that would result in me having to do this in order to call that method. By saying from copy import deep copy, I'm just simply saying give me the one method that I'm really interested in here, and I'm going to refer to it by that name. So now that we have imported deep copy, all that I would need to say is we'll say DC list for deep copy list gets deep copy, and then we'll say orig list, the original list. So here we are recursing through the original list, meaning we're not just going at the superficial level, at the shallow level, and scraping off the data that we see, making references to the data. For the collection data types, we are going to now go into those other lists, and we are going to fully create independent, mutually exclusive copies of every object in those element lists. So let's check that out. Let's say ID DC list. And as you can see, that is not the same ID of any of the other lists. So 9840, if we were to scroll back here briefly, you can see that all of these other lists, none of them end in 9840. I believe it was 98. Yeah, 9840. So now that we've created this deep copy, let's take a look at DC list. And in fact, it does show those changes because, again, we made a copy, a deep copy of that original list, which had been changed. But now let's see what happens when we do something similar, and let's fix this list. So if I was to say DC list, and we'll go to the first element, which is the first list at index position 0, and I'm going to change the first element in that sub list. And I'm going to change it back to what I wanted it to be, which was a 1. And then let's come back here and we're going to say 1 and 1, and we'll change that back to a 5. And then finally, we're going to be able to just drop a negative sign in here and say -1, -1, and we're going to change that back to the number 9. Now, as we would expect, when I say DC list, you can see that we have now changed this list back to the original state that we had with original list. However, what about the ID location? Still the same? And it will be because, remember, lists are mutable, meaning they can be changed in place. And that place is memory, and that's the location in memory where this list and its values reside. So the big test is to say, okay, well, did this change original list? It did not. Did it change first list or second list or third list? And it did not, because it's a deep copy, meaning it recursed down into these collection data types when it was performing the copy and went in here and created independent, mutually exclusive objects for each of those. Now, the question often comes up, why is it that Python, with the 3 methods we have to create a copy of the list, would create a shallow copy. And the idea behind it is typically you're not going to be in a scenario where this is something that you might be doing. However, if you are, you would know that you would want to create a deep copy to ensure that you've got independent, mutually exclusive objects in the new list that you've created that is a deep copy. Now, one question that will come up is, okay, well, what happens when I say num list and I create this list of numbers like this? Sorry about that. I create this list of numbers like this, and we take a look at num list, and then I decide, okay, well, I'm going to create a shallow copy of num list. So I say num list, and again, any of the 3 ways, and we'll use the list function to do that. I'll say num list 2, and let's create a copy of num list. So now if I say id num list or id numList2, you can see we get a new list. Now, let's see what happens when I do the following. If I go to our new copy, numList2, and I go to the last element in that list, and I change it to a bunch of 9s, now when we look at numList2, we see the following. However, what about numList? It hasn't been changed. And again, remember that the reason for this is that those are integers. Those are not collection type objects or objects that are used to collect up other objects like a list. And so you won't see that same behavior here. Now, the final thing I want to cover is what happens when I say numList is, or let's say numList3 is going to get the value of the original number list. Have I created a new copy of that list? And this is important. So I have not, and we can check that by saying id numList and then id numList3. And as you can see, what this does, and you'll notice I did not use that syntax in the example of creating shallow copies because this is not creating a shallow copy. This is simply creating another reference to the already existing list. In other words, as you see right here, both of these references, these variable names, are pointing to the same location in memory. i.e., in other words, they're pointing to the same list. And the same is true if I was to say numList99 gets the value of numList3. And so now when we say id numList99, it is actually pointing to the exact same list. So all we've done with that last series right there is create 2 additional pointers, 2 additional references to the same location in memory to the same list. So if that's true, then what if I say numList.append, and I'll just put in 88888, and then what if I say numList3.append, and we'll put 7777, we'll throw some 7s in there, and then numList99.append, and we'll put 55555. Now the question is, did I just change the same list? So in other words, when I say numList, I do see the changes. What about numList3? Absolutely, because remember, those are simply references to the same list, which is different from what we saw up here. Remember, up here, when I created a copy, a shallow copy, using the list function, you get a new list in a new location in memory. Remember, this is all about the shallow copy and deep copy is all about those collection type objects that are inside of that list that was copied. Here, we're just referencing the exact same list. There is no copy that has taken place here, and hopefully this has driven that point home. All right, well, that is going to wrap it up for this video tutorial on the difference between a shallow copy and the implications of the shallow copy. And we saw 3 different ways to do that: the list function, using the copy method, and using the slicing notation with bracket, colon, bracket. And then we looked at the deep copy, which is where we do a recursive creation of the new list, generating mutually exclusive, unique objects that are inside of these different collection data types that we might have inside of our list. All right, well, thank you so much for watching. Please let me know if you have any questions, and looking forward to seeing everybody on Thursday evening.